All right, so 11.3 geometric sequences. Let's look at definition. All right, so the definition of a geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. And the amount by which we multiply each time is called that common ratio. It's the common ratio of the sequence. All right. All right, so first example that they give, write the first 6 terms of the geometric sequence with first term 6 and common ratio 1/3. All right, so remember we talked about this last class. They told us our first term, and that is 6, so that is included as a part of our sequencing. So our second term is going to be 1/3 times 6, which is 2. And 1/3 times 2, which is 2/3. 1/3 times 2/3, which is 2/9. We'll just keep on with the same pattern. 1/3 times 2/9, which is 2/27. And then the last one, 1/3 times 2/27, which is 2/81. So those would be your first 6 terms. All right, any problems? All right, so here we have the general term of a geometric sequence. A sub n is equal to a sub 1 times r to the n minus 1 power. The n minus 1 is an exponent. So a sub 1 is going to be your first term as normal. A sub n is your nth term, but r is that common ratio that we discussed. All right, so we want to find the 8th term of the geometric sequence, whose first term is -4, and common ratio is -2. So we got the 8th term where n is going to be 8, a sub 1 is -4, r is -2. So if we were to plug them into the formula, we go back here, n is 8, a sub 1, -4 times r, which is -2, raised to the 8 minus 1 power. I guess I didn't need the dot. So it's -4 times -2 to the 7th power. So -4, -128. And -4 times -128 is 512. All right, any problems? All right. So now we're looking at the sum of the first n terms of a geometric sequence. So S sub n, a sub 1 times 1 minus r to the nth power over 1 minus r. All our letters hold true to what we've held them to before. That just represents sum. All right, so let's find the sum of the first 18 terms of the geometric sequence. We have 2, -8, 32, -128, and so on. All right, so in order to find the sum, we need a sub 1, which we know is 2. That's just your first term. The one that it gave us was n, so we really could have started there. N is 18. And now we need the common ratio. And what we can do is take a sub 2, place it over a sub 1 to figure out what did you multiply to a sub 1 to get a sub 2. So it'd be -8 over 2, which is -4. And if you look at going to each term, you can always check that by multiplying it by -4 and see if you get your next term. And that would be the case in each case. All right. So from there, we're looking at S sub 18. So that'll be 2 for a sub 1, 1 minus -4 raised to the 18th power. So make sure you know how to use your calculator unless you really want that problem. Minus, oh, it should be -4. All right, and of course you can put that in parentheses when you put it in your calculator, and then that's all you have to do is put it in the calculator in that way. And your answer should be -27,487,790,694. So that's what you get when you add up all 18 terms. All right, questions? Any questions?
No.
All right, sounds good, sounds good. I think there's one more thing that they talk about in this, yep. The sum of an infinite series. So here, this is considered partial sum when you add to a certain term. Here we add it to the 18th term. But the next thing we're looking at is a sum of an infinite sequence or series, infinite geometric series. And so how we would be able to find that. And when you get into calculus, this will be the difference between a series converging versus diverging. So you're talking about convergence versus divergence. Does it approach a number, or does it just continue to get larger or continue to oscillate? You know, those things you would explore when you get into calculus, and there's those foundational things here. So we have -1. Series, not sequence. You want to write sequence. Excuse me. All right, so the sum of the infinite geometric sequence series, if r is greater than -1 or less than +1. So in other words, you're talking about absolute value of r is less than 1. Absolute value of r is less than 1. I wrote the twice. Nobody said anything. It's all good. Y'all supposed to catch that. The sum of the infinite geometric series is given by this right here. So the sum is equal to a sub 1 over 1 minus r. So now, if the absolute value of r is greater than or equal to 1, the infinite series does not have a sum. Like I said, this goes back to convergence versus divergence. Does it converge down to a number, or does it continue to do something outside of that? So whether it has a sum or not will be dependent upon what you figure out r to be, or what they tell you r to be. Now, don't get this twisted or confused with what we did in the previous example. The previous example had a sum because your terms ended. You know, they said 18 terms. Take your 18 numbers, add them together. Here we're talking about an infinite series, a series that does not end. Will it have a sum? And you know what happens here is that when you start talking about going on to infinity, some values will begin. Your values could possibly continue to get so small that when you add it to something, it doesn't matter anymore. So that's what happens in a lot of cases. So let's look at this next one. And that's why R has to be, you know, in between -1 and +1, because that effect has to take place. All right, so we're going to find the sum of the geometric series. We have 3/8 minus 3/16 plus 3/32 minus 3/64 on to infinity. So remember what dictates whether we have a series that has a sum or not is dependent upon what R is. So we need to figure out what R is. Remember, the easiest way is just to go ahead and take a sub 2 and divide it by a sub 1. You know, this one is a1, this one is a2. So we're looking at negative 3/16 divided by 3/8. And you already know how that works if we're dividing fractions. Multiplying by the reciprocal. Threes cancel. 8 cancel. Leave you with 2. So we're looking at negative 1/2. All right. So it's absolute value. All right, so since R is equal to negative 1/2, that means the absolute value of it is going to be less than 1. Then this sequence has a sum. All right, so we can go ahead and find that. I'll just write it out right here. A sub 1 over 1 minus R. A sub 1, 3/8, right? Yep, 3/8. 1 minus negative 1/2. And just go do your fraction work. Of course, that's 1 plus 1/2. 3/8, 3/2. And I am looking at 1/4. So the sum is approximately going to be 1/4. And don't forget the way this was set up, you know, you're adding a term, subtracting a term, adding term, subtracting a term. So they're saying infinitely, you keep doing that, adding, subtracting as you're doing your geometric sequencing by multiplying by R, it will ultimately give you 1/4. All right. Questions? We have one more example, then we'll be good to go. All right, the next one, there's a cheat code too. Some of you may already know it. But if you had to actually write out the work, we'll go over that. So we have express 0.7, you know, with the bar over the 7 as a fraction in lowest terms. So we're talking about 0.7, and go blue. Go purple. 0.7 repeated is going to be 0.7, you know, to infinity. Anybody already know what that fraction is? Anybody?
No.
Let me show you the trick. Everybody done writing that. Let me see. Somebody said something in the chat. Yep. Somebody in the chat said it. So whenever you have a repeat, now this only works for single digits. Only works for single digits. 0.1 repeated is just 1 over 9. 0.2 repeated is 2 over 9. And keep on with the same pattern. 0.3 repeated is 3 over 9, which most of us know to be 1/3. Same thing with 0.6 repeated is 6 over 9, which most of us already know is 2/3. And that goes for 0.7 repeated is 7 over 9. And even, but then also don't forget, 8. Well, when you look at, yeah, that's it. And it only works for 1 through 8 because, when you look at 9 over 9, that's 1. But for 1 through 8, whenever you have that digit, the single digit repeated, it's just that number over 9. So, yeah, if you were to get that, then you would just write 7 over 9. But the work behind it, though, when we talk about how does that apply here? We got 0.7 repeated, like I just mentioned. That's that. But also, if I want to write this representing it as a sum, and I'm looking at each, digit, that first one is going to be 7 over 10 plus the next, which is 7. This is the tenths place, hundreds place, thousands place, 10,000 place, 1,000, and then 7 over 10,000, and so on. All right. So if I were to look at this geometrically, there's a geometric sequence. That means that a sub 1 is equal to 7 over 10, and then r is 1 over 10, because that's the only thing that's changing. From 7 over 10, you multiply that bottom by 10, that'll give me 100 in the bottom. Multiply the 100 by 10, it gives me 1,000 in the bottom. Multiply the 1,000 by 10, I get 10,000 in the bottom, and so on. All right, and I could have done this for, this goes here, this applies to this one, that one, and that one. And so now, if I were to throw a sub 1 and r into the formula to calculate the sum, and a sub 1 on top, that's 7 over 10, and then 1 minus r on bottom, which is 1 over 10. 7 over 10 over 9 over 10. And finish off the work. Those 10s cancel. And that leaves me with 7/9. And I put a 10 strong. There we go. So that's how you would do it. That's how you would work it out. But if you were to see that single digit being repeated, in the homework, and they ask you this, really, unless you just really want to do the work, you can just lean on what I mentioned here with any single digit being repeated behind that decimal. You just put that number over 9, and that'll be the fraction. All right. Questions, anything, anybody? That's our last section for the semester.
No questions.
All right. Sounds good. So from this point forward, it will just be me checking in and seeing if anybody have any questions. If you have them, you can bring them. If not, let's see. So we're looking at, today is the 3rd. We got the 3rd, the 8th, and the 10th as far as for questions. The 3rd, the 8th, and the 10th for questions. If you have questions, feel free to bring them. If you do not, then it's okay. You don't necessarily have to come to class. I'll be here. If no one shows up, I'll put in the requisite 15 minutes to see if anybody's going to show. If not, I won't look at anybody sideways. Sideways. All I'm doing is sitting in my house, so I didn't waste any gas. So you good. So, you know, if you have questions, feel free to show up. And that's questions on anything. Remember, everything in my math lab is open. So you may have questions on something that you may have tried in the past, or might want to raise a grade somewhere. That's fine as well. But from this point forward, it will be your time. And then on the 15th, we come in ready to take the test. Yes, you can use the notes. Um, so that, you know, take great notes. Make sure you're labeling your, if you decide to use notes, I see a hand clap for that. If you decide to use notes, make sure you are labeling your formulas properly, and then you make sure, in other words, look at the review. Even if you don't do the review, remember the reviews aren't mandatory. At least look at them, check out the order, make sure you're seeing where they are, because you know finding the sum of geometric sequences or series is a little different than finding the sum of your arithmetic series. So those are two different formulas. So you want to make sure you use the right formula at the right time. So make sure you're labeling stuff properly, have your examples in front of you, and you should be good to go. You know, should be good to go. Questions? Questions? Any questions? Everybody good? All right. All right. So, if you have any questions, though, I see a thumbs up. If you have any questions, never hesitate to email me, and we'll go from there. Outside of that, if you guys are good, I'm good. I'll see you on next class. I see something in the chat. Let me make sure we're straight. Oh, yep, no problem. Not a problem at all. So anything you use up to this point, you still can use on your test. I'm not going to create a lockdown browser or anything like that for you guys to, um, to be attacked, I guess you would say. Only thing that I ask is that you have your camera on throughout the whole test, and make sure you show ID, throw it up to the camera to prove that you are who you say you are, and then knock out the test, and we'll be good to go. All right, so everyone have a good one. Be safe. I will see you on next class, whichever that next class is for you. It might not be to the 15th if you are good to go. Yes, you can make a study guide. I will not strip that away from you. I would suggest that you do so to make sure you have a guided way to knock out this test. As long as your guide is not a whole nother body, like as long as you're not bringing another person into the equation, I am good with you, your notes and stuff. All right. Book. Yep. I mean, I'm not going to stop anything as long as you're not bringing in a person. Then I am good to go. Let's see. It's a game on. All right. Sounds good. Outside of that, I will see you guys on next class. Take care.
Take care.
All right.